Alright guys, there's a request that came in for forward and reverse contactors. This is just electrical interlocks and mechanical interlock. Nothing to do with push button interlocking. We'll do another video on that later on. So let's see, we're going to label this guy as our forward contactor, this guy as our reverse contactor. And looks like we have our electrical interlock. So there's our electrical interlock right there. Meaning that in series with each of the coils, we have the normally closed from the opposite contactor. In line with this reverse, I have the normally closed of the opposite contactor. So that when the forward's on, this will open and not allow me to turn on the reverse. When the reverse is on, this is open, not allowing me to turn on the forward. Okay, once we hit this forward push button, looks like current goes through the stop, through the push button, through the normally closed to the forward, through the overload, and back to line 2 in this case. So we need a holding contact. So there's our normally open holding contact for the forward. And we have a normally open holding contact for the reverse. You can see that this right here is a 3-wire. Normally closed stop, normally open start, and a holding contact. So we have a 3-wire for the forward. Then we have a 3-wire for the reverse that's superimposed on top of that with a normally closed stop that's shared between the forward and the reverse. Then we have our normally open initiating push button, and then we have our normally open holding contacts there as well. Okay, so this is our electrical interlock. And in addition to that, we also need mechanical interlocks. So we're going to draw in these dash lines, and they denote the mechanical interlock that stops the forward and reverse contactors from turning on at the same time. Now, if you're doing the shop projects, they will ask you to keep these guys out. So initially, they'll say, keep those out and see what happens. Well, if those electrical interlocks are out, and I have pressed the forward push button and I'm running in the forward direction, then there's nothing stopping me from allowing current, if I press this reverse push button, from getting to the reverse contactor. So without these normally closed electrical interlocks, if you're in the forward direction and you hit the reverse push button, current is able to get to the reverse contactor. And at that point, the only thing that stops the 2 lines from blowing up is the mechanical interlock. So if the forward's running and I hit the reverse and I don't have the electrical interlocks in there, then as soon as I hit the reverse push button, this contactor is going to go meaning that both of them are trying to turn on at the same time. And so they make that sound like a machine gun. And they're continuously trying to turn on and turn off, and you'll eventually blow out the contactors. So we throw in these electrical interlocks for additional safety. Okay, taking a look at the actual diagram for your motors. So this is your power circuit here. Let's see, what are we missing? We're missing some fusing on this diagram. So we'll throw in some fuses here on each of our lines. Okay, those are time delay fuses to allow the current to go to the motor, get the motor up and running, and allow that large inrush of current to the motor. Then we have our forward contacts. We have 3 contacts for the forward contactor and 3 for the reverse. So why do we put in that electrical interlock and the mechanical interlock here? There must be a major reason why we don't want the forward and the reverse to turn on at the same time. Well, let's see. If all 3 of these were closed, meaning that the forward and the reverse were on at the same time, let's see what fuses will blow. Well, if we take this guy from line 1 and we go over here, we see that line 1 goes to line 1 on the top, but then on the load side it goes to line 3. Normally the current would rock down here to the motor, but if the forward contactor is also on at the same time, we have a clear path right back here to line 3, and we've got a short between line 1 and line 3. Smoking a pancake. Those 2 fuses are going to blow. Not only will the 2 fuses blow, but there's a chance that these contactors here may blow up in your face as well. Because when we're shorting out 2 lines, there's a massive amount of current that's going to flow. And if it's above the ampere interrupting rating of each of these contactors, then they may blow up in your face. So that was one part. There's also a path over here from line 3 down here, coming over here to line 1. Normally, that just reverses the direction of the motor. But if we've got the other contactor contacts closed, then we have a clear path from line 1 to line 3 again. So the reason why we have that mechanical interlock between the forward and the reverse is strictly to make sure that we do not have the forward and the reverse contactors turn on at the same time. If we do, then we're going to blow 2 fuses and cause a huge safety risk. In addition to those fuses, we are missing the normally closed contacts. So these guys will also come with normally closed contacts on both the forward and the reverse. And we need those guys to create this electrical interlock. Normally open and normally closed contacts for each of the contactors. So these contacts right here are horsepower rated. They allow a lot of current to go through. These guys are strictly for our controls. So they're going to be have less of a current carrying capability than these contacts that are going to the motor. The coils A1 and A2, we'll have to find those on the contactors on the next slide. In addition to that, we have the overload here. So we have an overload unit, and it's got 3 heaters that allow the current to go through the heaters. And before we blow up the motor by having too much current going to the motor, each of these heaters will heat up. And we have a normally open that's held closed contact here, that when this trips, this opens. And this normally closed contact for the overload heaters is, this bad boy right here. So if that opens, then that is in series with the forward and the reverse, and that takes out the current to either one of the coils. And when we take out the current to either one of the coils, then both of these contactors will open and stop the current from flowing to the motor. Okay, let's take a look at the actual contactors. Here's an IAC, not an IAC, this is a Nema contactor. So we can see the size of the contactor. It's a Nema size 0. There is a chart for the Nema sizing based on your horsepower requirements and your voltage requirements. For these guys, we can see that the voltage capability of the contacts for the motor, so between here and here, then sorry guys. Donkey, hang on. Okay, so let's try that again. So this voltage right here, the 600 volts, that's for these contacts right here, right? 600 volts from line to line. The actual coil, though, is only good for 120 volts. So be careful with this one. If you have a 600 volt motor that you're feeding, then you're going to need to have a control transformer to step down the voltage for all of your controls. The coils on either one are only good for 120 volts. Okay, what else? We've got different horsepower ratings. It's hard to make out. It's a little bit fuzzy here. But for 230, we got 101 horsepower. Here for 460 or 575, we've got, looks like 1 horsepower. Hard to make, I don't know, hard to make out there what that horsepower is. We'd have to look in the chart to see what it's good for. The 575 is there because it's 600 volts supply, but they're allowing for a voltage drop from the supply to the actual motor. What else have we got? Physical placement of these contacts. So we've got their normally open contacts, and we've also got the normally closed contacts, right, that we need to find on this contactor. So the normally open contacts are right here and right here. Those contacts are mounted right on the top here. Those are our normally open contacts. The normally closed contacts on Nema starters are right here. There's one, and there's another one right here. So our coil is right here, A1 and A2, A1 and A2 for either one of the coils. Then we've got normally open contacts for our holding contact, and then we've got our normally closed contacts that we're going to make use of for our electrical interlocks. Inside each of these guys, we have the 3 contacts that go from the line to the load side. So within here, we've got 1, 2, 3 contacts for either one of these guys, right? 1, 2, 3 contacts that when we turn these coils on, these contacts will close. If we're trying to just troubleshoot something, they also allow you with this, where you can put your slot screwdriver in, push against that, and that will actually close the contacts manually on the starter. When you let it go, there's a spring that pushes it back and brings it back to its open state. Okay, so now we know where all the different components are on the Nema starters and where to get the information from the nameplate and for a coil. In addition to that, down here we have that overload relay, which corresponds to this guy right here. And this normally closed contact is usually right on the bottom there. So there is a normally closed contact there for the overload that will trip if any of these heaters right here, here, and here heat up and open up that contact. The mechanical interlock is on the back here. There's a massive mechanical interlock between the forward and reverse contactors for Nema style contactors. Much larger than the IEC. I'll show you the IEC in 2 seconds. This is 2 different styles of contactors here. Again, there's our coil contacts. Then for either the forward or the reverse, we have our holding contacts. There's our normally open holding contact here and there for the reverse. And we have our normally closed contact for the electrical interlock for both the forward and the reverse contactors. All the information here, the sizing of this Nema contactor is right here in voltage ratings. And what else do we got? We've got the line 1 connections here, T1 down here, line 2, T2, line 3, T3. And the jumpers going from line 1 to line 3 are done with these jumper bars. You can see that you can just make out that there's bus bars that go right here to here. So that the bus bars are already done, or the reversing of the motor is already done from the manufacturer. If we go back 1 slide, there's the wiring for the forward and the reverse that's already done. So you don't have to do that. It's done from the manufacturers for you. Okay, overload relay right here with our heaters. 1, 2, 3 heaters. And then it looks like right here is our normally closed contact for the overloads. Again, 1 overload unit is used for both the forward and the reverse. So that's your Nema style. For this one, the mechanical interlock is actually underneath that little plastic sleeve. But it's a really beefy mechanical interlock between the forward and the reverse. These are the IEC style, and the mechanical interlock between the forward and the reverse is that little tiny piece of metal that is within this plastic housing. So if you're allowing the forward and the reverse to turn on at the same time without those electrical interlocks, then both of them will turn on and they'll snap this out of its plastic housing. So you can see that the IEC are much smaller, but they're not as beefy and won't hold up as well as the Nema style. Let's rock through the different parts of these contactors. We've got our main motor contacts, 1, 2, and 3. 1, 2, and 3. And then we've got the ones that go to the motor here. So here we have T1, T2, and T3. We have the 2 contactors within here. We're going to have our main motor contacts, which are horsepower rated on either one. In addition to that, we need to have normally open contacts for our holding contacts. So let's find out where those guys are. Well, they look like they're right on the front here. There's a normally open contact. There's a normally closed. And right here and here are A1 and A2 for the coil. Again, normally open, normally closed for the reverse coil. And there's our coil contacts for the reverse contactor. In addition to that, we have an overload unit on the bottom. The beauty of these guys is that you can dial in your overload setting. Looks like we can go from 4 to 6 amps. You can test those guys out as well. So there is a test button just below here. You can take a little slot screwdriver and move it over and test the overload. And that will open up the normally closed and close the normally open. The beauty of having a normally open here is that for the IEC, you can also have a signal going into maybe a PLC to say that you're in overload state, or maybe you just want to have an indicator light to show that the overload has tripped. Okay, this is just a single contactor with a little bit fuzzy photo here, but you can see that there's the overload, and you can see that the overload has these 3 jumper bars. They slide into these terminals here, so you really want to make sure that these 3 terminals on the contactor are tightened down so that they grab into the copper bus of the overload unit. Okay, the mechanical interlock for the IEC is just this small little piece of metal that's in this plastic housing. So, like, ridiculously small and prone to breaking if you had both the forward and the reverse turn on at the exact same time. So that's why we throw in the electrical interlocks to stop both of the forward and the reverse from turning on at the same point. But the Nema style are a lot beefier and will last a lot longer than the IEC. Okay, not the best photo here, but there you can just see that mechanical interlock in between the forward and the reverse when you slide them together. Okay, again on the IEC, the jumpers for the main motor contacts from line 1 to line 3 are already done for you. So these guys are the bus bars. They're embedded in plastic. And so when you tighten down your line 1, line 2, line 3 contacts, then they will grab those bus bars and they'll provide you with the jumpers already. You can see there is the voltage rating of the coils for the IEC. I hate the fact that they're on the top there. If you're short and this is mounted inside of a box, it's very hard to see that voltage rating of the coil. Again, the rating of your main motor contacts and your coil could be different. This could be for a 120 volt, but we could have 2 8 volts for our lines, and our coil is only good for 120. So always look at the voltage rating of all of the components on each of these contactors. You can see right here and right here that we have these little pivots here, and we have additional contacts that we drop in on the top of both our forward and our reverse. So there's additional contacts that you can drop in on top of your standard starter. You can see that the standard starter is right here and right here, right? The additional contacts are these guys right here. So they give you additional normally open and normally closed contacts to make use of. Okay, on the bottom end, you can see that for this IEC, it looks like on the load side, everything is the same. You can just make out with this diagram right here that, oh no, let's see, T1, that's where the reversing is going on. T1 to T3, T2 stays the same, and then T1 to T3 as well. So the reversing is done on the load side of the contactors on both the Nema style and the IEC. These again are already done for you, so don't try and rewire these contactors to provide that reversing. It's already done from the manufacturer. So that's it for this video, guys. Hopefully I've given you a good synopsis on the forward reverse. If you have specific diagrams that you'd like me to present, or you have any feedback for any of my videos, leave them in the comments section. So we'll stop here, and the next video that you might want to look at is the push button interlocking for forward reverse control. Thanks very much, guys.